All right, here we go. We're going to look at rational functions again. And today we're going to look at different functions that might have a hole. So in class, we talked about what does it look like when I have a vertical asymptote and an x-intercept at the same point. We're going to go through an example like that. So if I had a function in this form, like if I have y equals, remember we could have y equals or we could have f of x or g of x, and both of those are really telling us the same thing. So if I have y equals x squared minus 4 over x plus 2. Now this, we can find all sorts of things out about this, right? So our x-intercept, first of all, is when we set y equal to 0. And when we solve this, you'll end up and you'll get your x-intercept at 2, 0, and negative 2, 0. So as we keep going, you should be able to do some of this in your head. Your y-intercept is when we set x equal to 0. So we'd have 0 squared minus 4, which is negative 4, over 2. So we get the point 0, negative 2. And then our vertical asymptotes are when we set our denominator equal to 0. So our denominator equal to 0 would give us the equation x equals negative 2. Now if I were to sketch a graph of these first few characteristics, then I get a point at negative, or at 2, 0, and negative 2, 0, 0, negative 2 on the y. But I also have a vertical asymptote when x equals negative 2. So remember, that's a vertical line. That's why it's a vertical asymptote. At x equals negative 2. So if I draw my vertical asymptote, remember that my vertical asymptote is a line where my function approaches, but it never touches it. However, my function is telling me that I also need to have an x-intercept at this point of negative 2, 0. Well, those two things are contradictions of each other. So we're going to go into the math as to why those are contradictions. So something we can do to figure that out is we're going to factor this function. So in your practice 3, you would factor these on the backside on number 5. You also have to factor. So similarly, you're going to use RS to factor this. So when I factor it, I'll get y equals x plus 2, x minus 2 over x plus 2. Now, you notice that on the top and the bottom that we have x plus 2 on both of those. Well, x plus 2 on top and x plus 2 on bottom, if I simplify that, like any other fraction I've had, I simplify that, then those really divide out and they become 1 over 1. So these two end up going away. Also, I can think about if I plug in negative 2 into that place, right? Into this space right here. So you don't have to write this, but I just want to explain another part of this to you. So they cancel out. But notice if we plugged in negative 2 there, which is what we had for, which is where we got that contradiction. If I plug in negative 2, I get negative 2 plus 2 times negative 2 minus 2 over negative 2 plus 2. Well, negative 2 plus 2 is 0. 0 times negative 4 over 0. Well, I know that that's 0 over 0. So the question is, what is 0 over 0? Well, 0 over 0, we could say that it equals 1 because we have the same number on top and on bottom. We could say that 0 over 0 is equal to 0 because 0 is on top. Or we could say that it's equal to undefined because 0 is on the bottom. So this is a question that mathematicians have wrestled with for a long time. And now, so your calculator, it'll probably say something like undetermined or undefined. But none of those really satisfy what's going on the graph there. So if we think about this, we really want to know what's happening on this graph. And if we canceled out these common factors like we did, we know that we're left with this equation, y equals x minus 2. Well, y equals x minus 2 is just a line. So with a y-intercept at -2 and a slope of 1. So we'd go up 1 over 1, up 1 over 1, right? And we'd hit both of these points. So we know that lines, they continue, but they don't, something happens at -2. So we have to keep in mind the whole function, because at -2, we get 0 over 0. So what we call that is a hole. So to find the hole, I'm actually going to move this over. So to find the hole, we factor, then we simplify. So notice how we factored this out. That's how we got this part here. Then we simplified, we canceled our like terms on top and bottom. And then we take where it's the contradiction, so where we have an x-intercept and a vertical asymptote, and we use that value to figure out where the hole would be. So I'm going to plug in to what's left here, and we're going to call this y star. The reason we call it y star is because it's a function, but we have to remember that our whole function includes this denominator. So our function would end up being a line if we just used y star, but we have to remember that we had this denominator before. So we plug in the contradiction into y star. So our next step is plug, in this case, x equals -2 into y star. So when we do that, we get y star equals -2 minus 2. So then y equals -4. So we had an x value of -2, and we have a y value of -4. Wonderful, I got a new attendance pool. Awesome. So this is the ordered pair where our hole will be. So instead of having a vertical asymptote or an x-intercept, now I just have a hole there. So if we look at the whole page, we can get rid of the vertical asymptote. Sorry to those of you who may have written in pen. And we can draw that hole in. Maybe go down 2 more. So at -2, -4, I have a hole which will draw as an open circle. And then notice how my slope continues. So if I go up 1 over 1, up 1 over 1, I will run back into that line. So this becomes just a line in both directions. So that is the function. Sorry, my drawing doesn't look totally like a line, but it should look like a line. So that's one example. Another example we might have would look like this. So example 2. Y equals over x squared minus 4. Let's say this is our example that we have. Now, what we can do here is sometimes factoring it helps also to find all the other parts of the function as well. So I can factor this. I would get x minus 3 times x plus 2 over x minus 2 times x plus 2. So if I want to find each part of this, my x-intercept, I'm going to graph it over here. My x-intercepts are at 3, 0, and -2, 0. My y-intercept is at 0, 3 over 2. my vertical asymptotes are at x equals 2 and x equals negative 2. And then I notice that I'm going to have a hole. So the hole is going to happen when x is negative 2. And we have to figure out the y value. So we're going to use y star. And y star, after I cancel out, so negative 2, if I plug it in here, it would give me 0, and here would give me 0. So I can cancel those out. And I'm going to plug negative 2 into y star, what's left over. So negative 2 minus 3 over negative 2 minus 2. So y star, we get negative 5 over negative 4, which is 5 over 4. So when we graph this, we're going to no longer have this x-intercept and no longer have this vertical asymptote. So let's plot what we know. We have a vertical asymptote at x equals 2. We have a y-intercept at 3 over 2, 0. We have an x-intercept at 3, 0. 1, 2, 3, 0. And we have a hole at negative 2 and 5 over 4, which is just above 1. Now, we have one more part that we'll have to get to, which is called the extreme. But we'll leave this image as it is for now, because we'll get to the extreme in our next video. So as for now, I just want you to think about, how do we get this hole? How do we cancel out our common terms? Because if we plugged this value in, then we would end up with 0 over 0. So 0 over 0 gives us that hole. So this should help you answer questions on practice 3. And then you should have these two notes in your, or examples in your notes. Notice how here we have only partially a drawing, but that is all we need for now, and then we'll figure out the last part to come.